The next speaker is Markus. He'll be speaking about MapLibre Tiles, a next generation vector tiles format specially designed for OSM data.
Okay, so warm greetings from Germany, and thanks for listening to my talk. Also, I cannot attend the conference in person due to another important commitment. I'm excited to share our work with you through this video. I will be joining you live for a Q&A session immediately afterwards. So, in this presentation, I will discuss our work on a new vector tiles format called MapLibre Tiles. This format is built upon the awesome Mapbox Vector Tiles specification, which has become the de facto standard for vector maps. But with the MapLibre Tiles specification, we have redesigned the vector tiles from the ground up to address emerging challenges, such as a continuously growing amount of data or the efficient support of modern and next-generation graphic APIs. But before going further into details, let me introduce myself. My name is Markus Tremmel, and I work as a software engineer and architect at a company called Rohde & Schwarz in Germany. I also teach vector data processing as a lecturer at the Deckendorf Institute of Technology. And one of my main work focuses is on researching and on the development of the next generation map rendering stack, meaning from deploying big geospatial data in the cloud up to rendering the vector data on the client on the GPU. And if you want to get in touch with me, you can find me on Twitter, GitHub, or drop me a mail. Okay, so I want to start by highlighting one interesting activity that is happening in parallel to our work at MapLibre on the new vector tiles format. And these are the efforts of the OpenStreetMap Foundation to introduce vector tiles on the openstreetmap.org website this year. So the OSM Foundation has announced this year as the year of vector maps, which means that in addition to a raster tiles, OSM users then also can utilize the advantages of vector tiles on the OSM website. This also highlights the importance of vector tiles for the visualization of maps. Just a short disclaimer, to be clear, I'm not involved in this initiative, nor is MLT used. So, because mainly MLT is not production ready, and OSM is with high probability building on Mapbox Vector Tile, on the Mapbox Vector Tile specification. But maybe in the future, hopefully, OpenStreetMap could also switch to MLT when we are production ready and integrated into the different map rendering libraries. So the question is, why now OSM is also adding support for vector maps in addition to raster tiles? So which advantages do vector tiles have over raster tiles? And in the following, I want to give you first a short introduction of raster versus vector tiles and show you the advantages and disadvantages of both approaches. So with raster tiles, which is used since many years in OpenStreetMap, you have basically pre-rendered images of the actual vector data. And these vector data or these images are encoded as PNG, JPEG, or on a newer format like WebP, for example. And like you see it on the left with raster tiles, but also the same with vector tiles. So in general with map tiles, the full planet or the full data set is divided into different zoom levels. And every zoom level is then divided into different small pieces called tiles. So for example, if you take zoom level 0, you have just one tile, and because it's then a quadric data structure, which means then every zoom level is divided by 4, which means zoom level 1, then you have 4 tiles, in zoom level 2 you have 16, and so on. And with raster tiles in the traditional traditional resolution, every tile has 256 pixels by 256 pixels. Or if you have high resolution tiles, then you have 512 by 512 pixels. So, and now compared with vector tiles, you have the same approach, but now that a tile do not contain a picture of the vector data, it contains the actual vector data. Normally, these vector tiles are based on the simple feature access model of the OGC, which means the vector data are encoded as points, lines, or polygons. And also, this has now the advantage that the vector data are rendered on the fly on the client, usually with the help of a GPU. So in the browser, you normally use WebGL, or probably currently you can just use WebGL in the future, or currently also WebGPU is arising, but the standard at the moment and the widely used standard is WebGL. And like you see it on the right side here, on the right image, every tile, like I said, is now has now the raw vector data. And there are different possibilities how you could encode this vector data. For example, like on the right side, you could use a JSON, but the de facto standard for open vector tiles is the Mapbox Vector Tiles specification. So this is the industry standard used by small companies up to the big tech companies like Meta, Amazon, or Microsoft. Okay, so now when you compare raster tiles to vector tiles, which advantages do these new vector tiles or relatively new vector tiles have? So one main advantage is the dynamic styling which now can happen on the client. Like you see it on the right bottom side, you can now dynamically switch the layout or the style of the map. For example, if you can have a light or a dark theme or the classic OSM theme. And this is not or just hardly possible with raster tiles. Then you have a much better user experience. You have this, for example, smooth zooming, so not that hard zoom levels, which you have on raster tiles. You can, for example, rotate the map while the labels stay aligned. So you can also, if the map is rotated, you can still read the fonts. And then you have stuff like better interactivity. You can click on the map, on features, and you get the information immediately displayed. And one also very important advantage is we have significantly smaller tile sizes, which now enables real offline maps, also for planet scale maps, because basically a planet scale tile set fits on an, or nearly fits on a USB stick. Also raster tiles, because they are used since nearly two decades or even longer, have some advantages, like you don't need that powerful hardware because the tiles are already pre-rendered, so you need no GPU, which is in some cases an important aspect. So it basically works on all types of devices and browsers. Also, the map client implementation is much simpler. For example, if you compare Leaflet, which is basically a raster tiles renderer, or is basically focused on rendering raster tiles, compared to MapLibre Tiles, to MapLibre GLJS or MapLibre Native, which is quite much more complex. Okay, so the question is now why there's a need for a new vector tiles format. And there are basically 4 different reasons. So the first reason why at MapLibre we want to improve the current vector tiles or the industry standard of the vector tiles specification is we see a continuously growing amount of data based on the advantages on geospatial sensors and on software technologies, especially on AI. So there's a lot of automation going on in detecting geospatial data. Think on, for example, the automatic detection of Google or Microsoft buildings, so where nearly 1 billion buildings had been automatically detected based on convolutional neural networks, or has been processed with CNNs. Then we see also in the latest scientific publication, so in the latest research, that there are novel algorithms which significantly improve data compression and speed up the decoding and processing performance. We see, on the other hand, also new, more complex geospatial source formats. For example, if you think on the new initiative of the big players like Meta, Microsoft, and Amazon with Overture Maps, where you have, for example, GeoParquet as a source format, and you have then more complex data types, which cannot be handled with Mapbox Vector Tiles. And also, there are now new modern and especially next generation graphic APIs, for example, like WebGPU. And this has to be also be part of the design of a next generation vector tiles format. Okay, so now what are MapLibre tiles? So, like I said at the beginning, the MapLibre format is mainly inspired by the Mapbox Vector Tiles specification, but has redesigned from the ground. It is one important point. It is designed for current and next generation graphic APIs to enable fast rendering of a large 2D and 2.5D base maps. Then the geometries, as with MVT, are based on the simple feature access model. So basically, you have also in the tiles point, line, and polygons. And one important improvement is to combine a good compression ratio with fast decoding and processing. We divide the MLT format in a storage format and an in-memory format. And one important design aspect is also to enable a fast transcoding or decoding of the storage into the in-memory format. So the main new features of MLT over MVT you can find on this slide. So one main improvement is the improved compression ratio. So we get up to 6x on large tiles based on a column-oriented layout with recursively applied lightweight encodings. So one goal in the future is to make an additional heavy byte compression, for example, with gzip, Broadly, or ZSTD, unnecessary. So because in the latest research results, there's also a trend to going away from these relatively slow heavy byte compressions to more lightweight encodings, because networks are getting faster. Think of the 10 or 100 gigabyte networks, which you can find in the cloud environment. And yeah, it's more the case that the CPU getting more and more the bottleneck. Then we offer better decoding performance and also improved processing performance. So performance is really one key features of MLT, which we try to improve over MLT. So one is performance, decoding and processing, and the other is the size of the tiles. These are really two main aspects we have spent a lot of time on these topics. Then we add additional features. One is support for linear referencing or MValues to support the upcoming next generation source formats, such as from Overture Maps. Like you see it on the right side, before, if you had encoded you want to encode one feature, a street, for example, which has different type of services, you had to split it up in different features. For example, in 3 features. Now with MLT, you just can model it with one feature and have varying type of services. So you can more efficient model and store this kind of requirement. Then there's also support for 3D coordinates and also for more complex types. Like with MVT, you have just flat data types, for example, primitive types like string, double, integers, and now you can have nested properties, so structs, lists, and maps, for example. Okay, so like I said before, we divide it into a storage and in a memory format. And the storage format is mainly designed for the cost-efficient storage in low latency transfer over the network. It defines, and this is also important, a platform agnostic representation to avoid the expensive materialization cost, in particular for strings. And then one important design choice was to use a column-oriented layout, like very popular in a lot of different big data or in memory formats like Parquet or or error, for example, compared to the more record or row-oriented approach used in MVT. Like you see it, for example, on the left side, on the bottom left, you have this column-oriented layout, and every column is then compressed with a lightweight, SIMD-friendly encoding. And if we now compare these both approaches, that you get a basic picture of this approach, which we are using compared to MVT. If we look at this GeoJSON document at the top, and you look at the right side where you have an MVT, a representation of MVT, of the MVT layout, then you have a collection of layers in MVT and then a collection of features. And now the features are, or the different properties of the features are encoded one after each other. So it starts by the ID, then you have the attributes, like hello is one attribute with the value world, then again the age property with world, and then you have the count with 1.23. And then the next feature, for example, comes. In MVT, you have tags because everything is dictionary encoded. So for every layer, at the end, you have a dictionary for the values, and you just store references. But you can think of it like there are the different values encoded. And if you compare it to MVT, to MLT on the left side, you store, for example, all IDs of all features continuously in memory. So starting ID 1, then ID 2, and then on the next, the geometric columns comes where all the geometric types are stored, for example, point 1, then point 2, or the type, at geometric type point for geometry 1, and then for geometry 2, and then all X coordinates and Y coordinates. And then, for example, the first property column is continuously stored in memory, and then the second and the third. So this enables, on the one hand, much better compression, or a better compression ratio, significantly better compression ratio, and faster decoding and especially processing performance. Because now you can operate or directly work on, for example, all vertex data, so on all geometries, because they are continuously in memory and you have not such an scattered access pattern, which makes better use of the CPU caches, because you have less cache misses, and this significantly improves the performance. And then in addition, we also use an in-memory format. I will go a little bit faster because the time is running out over this. So this in-memory format is then used for the processing and the rendering of the vector tiles. It's mainly inspired by Apache Arrow, this analytics in-memory format, and the GLTF format, which forms the foundation for the 3D tiles format, which is the industry standard for displaying 3D maps. And it is important that it allows random constant time access to all data, so it can be parallelly processed on the GPU, for example, on web GPU compute shader or on other compute shaders, because this will be important for future map clients to allow parallel processing of the features of a tile. Okay, and finally, I want to close this presentation by giving you an update or an overview over the current status of MLT. So we currently have a first initial draft of the specification. You can find that specification on GitHub. Then we have an POC integration of MLT into MapLibre GLJS. Thanks to Microsoft, Stayman, Yuri, Dane, and Eric, which is showing that our concept is working, and we can also get the same rendering results as with MVT on the MapLibre GLJS rendering library. So then one important aspect is the compression ratio. We get up to 6x reduction on large tiles based on the MapTiles scheme, for example, without the usage of heavy byte compressions. This would be a separate talk to get further into it, when to use heavy byte and when not. But yeah, without heavy weight, with a 6x reduction, with heavy weight is not that much, but we work on that to also, if heavy weight compression is in addition used, we are convinced we can also get a significantly better compression ratio than MVT, or already have a significant better compression ratio than MVT, but also should reach the same results as without. And with the Microsoft Bing Maps tiles, which are really strong optimized, so there's a lot, only the necessary information are stored in Bing Map tiles, and it's harder to compress. We also get a 2x reduction, or up to a 2x reduction on the tile size. On the decoding performance, our first benchmarks on the Java decoder shown on average about 4x speed up of MLT against MVT when we decoding MLT into our proposed in-memory format, which I have showed you before, this in-memory format should then lay the foundation for the next generation of map, or of the current and next generation map rendering libraries for processing and rendering the tiles. When we then have implemented, or Dane and Eric have implemented it on a JS decoder, and in combination with MapLibre JS, we have currently then the problem that MapLibre GLJS has a different in-memory representation, which is not column-oriented, which is row-oriented, which is not that optimized. So we have to do an additional transformation, which is very costly, from the column into the in-memory format at the moment. Because of this, we are currently getting around about 2x slow performance of MLT against MVT. So on the middle or long term, we hopefully can use our proposed in-memory format, then it should show significantly a speed up. But as long as we cannot fully refactor MapLibre GLJS or MapLibre GL native, for example, we have to find, or that are the next step, an intelligent way to making this transformation into the row-oriented in-memory representation of MapLibre GLJS faster. Okay, and then thanks for listening, and I also want to close this presentation to say thanks to Microsoft for sponsoring the POC integration, then also to Stamin for doing this POC integration, which was the contractor of Microsoft, and especially on the MapLibre organization, that this format is now part of the MapLibre repositories, and also to Yuri Astrahan for doing getting financial support, for Dane Springmeyer and Eric Brailsford for doing the POC integration, and for Ante Viducis and Felix Fischer for contributions on the map, the POC research prototype. Then I want to wish you all a nice remaining state of the map, and thanks for listening.
Thank you so much, Markus, for the presentation. Are these tiles designed for Mikata, or are they pre-projected easily?
Yeah, so basically, one main design goal is also to support different coordinate reference systems, so it's not limited to WebMercator or to Mercator, so it can be used basically any tiling tile coordinate reference system. But it's up to the range. So the question is, from a technical point of view, is the switch from raster to vector tile possible in the main OSM rendering? So so I think definitely that's possible. This is which is very strong in rendering Mapbox Vector Tiles. The current MapLibre Tiles is not, like I said in the video, not yet ready for production, proof of concept integration, but we try to we have to bring that to production in the next months. But yeah, Mapbox Vector Tiles combined with MapLibre GLJS, which is tiles, and it's fully based on vector tiles. Yeah, is definitely can be used on most end devices which have support for OpenGL, ES, and WebGL, and that's basically most end devices currently have that support. And yeah.
Since there are no more questions, we will be moving on to the next speaker.